Welcome to This Explainer. Okay, today we're completely bypassing the cultural noise, right? No celebrity gossip, no endless social media debates. We are diving straight into the biology. We want to take a fascinating anatomical journey to understand exactly how medications like Ozempic actually function inside your body. I mean, we hear about this medication constantly, but unpacking the core biology of what one single weekly injection actually does to your internal systems, that is an entirely different and honestly a much more captivating story. Imagine waking up one morning and realizing those intense food cravings you've literally always battled are just gone. You sit down to that enormous meal you'd usually polish off, and halfway through, you're just completely full. That dessert you used to intensely crave, suddenly you can just take it or leave it. This isn't some sudden surge of willpower, guys. It's a profound shift in biology. So let's look at the biological chain reaction that makes this entirely possible. To truly get how this works, we're going to map the medication's path system by system. We'll start with number 1, the body's natural GLP-1. Then move to regulating the pancreas, check out the stomach and digestion, explore rewiring the brain, and finally, look at the systemic aftermath. Section 1, the body's natural GLP-1. We absolutely have to start with the baseline here, because before we can even begin to understand the medication itself, we need to look at a highly coordinated process your body already performs every single time you eat. Your body produces its own version of this chemical signal, and it's called GLP-1. Whenever you eat, your digestive system springs into action and basically sends this out as an alert. It's telling your internal organs, hey, food has arrived, nutrients are processing, we need to manage this glucose. It's basically a master coordinator that talks directly to your pancreas, your gut, and your brain to keep everything perfectly balanced. Now, the contrast here is absolutely wild. Your natural GLP-1, it vanishes super fast. It's rapidly broken down by the body, so it acts as a very short-lived signal. But semaglutide, the active ingredient in Ozempic, is structurally designed to mimic that natural hormone, but last way, way longer. Instead of disappearing in minutes, it sticks around like a long-lasting echo, actively changing your biological signals for an entire week from just one injection. And that gets right to the heart of how these core concepts function. Section 2, regulating the pancreas. So what exactly happens to your pancreas when that long-lasting semaglutide signal circulates through your bloodstream and reaches it? Well, it does something incredibly precise. It doesn't just act like a blunt instrument and flood your system randomly. It's a glucose-dependent chain reaction. It acts almost like a highly sensitive smart thermostat for your blood sugar. When you eat and your blood glucose goes up, the medication helps stimulate the pancreas to release insulin, which moves glucose into your cells for energy. But here is the kicker. It only does this when appropriate. At the exact same time, it suppresses a totally different hormone called glucagon, which normally tells your liver to pump out more sugar. By boosting insulin and suppressing glucagon only when your blood sugar is actually elevated, it creates this tightly controlled, super efficient response. This is literally exactly why it was originally developed to treat type 2 diabetes. Section 3, the stomach and digestion. But look, if it only affected blood sugar, it wouldn't have become globally famous for weight loss, right? To understand that part, we need to travel further down the digestive tract. How exactly does this medication physically alter the way your stomach handles the food you just ate? The mechanism at play here is called delayed gastric emptying. Semaglutide literally slows down the speed at which your stomach releases its contents into the small intestine. Imagine eating a meal, and instead of your stomach processing and emptying it in a couple of hours, the food just stays there for much longer. Because the physical food is literally just sitting there, those biological signals telling your body, hey, I'm full, persist for a significantly extended period. You get full sooner, and you stay full way, way longer. And this breaks down a crucial mechanical reality of how this drug functions. That exact same delayed emptying that wonderfully makes you feel satisfied sooner, it's the exact same mechanism that causes uncomfortable side effects. Think about it. If your stomach is emptying slowly, but you try to eat a large meal at the speed and volume you used to, well, the food arrives way faster than your slow digestive tract actually wants to process it. The biological result? Nausea, bloating, and sometimes even vomiting. The body simply needs time to adapt to this totally new, slower rhythm. Section 4, rewiring the brain. Okay, let's dive into one of the most fascinating parts of this whole story, because true appetite doesn't actually begin in your stomach. Your stomach could be completely empty without you actually feeling hungry. Or, on the flip side, you could have just eaten a massive dinner, your stomach is physically full, but you still intensely crave dessert. Which leads us to ask, how does the drug communicate with our neurological reward centers? Think about this frantic internal chatter we all know. What am I going to eat? Should I have a snack? I really shouldn't eat this, but I really want it. This is what patients and doctors are now calling food noise. It represents the exhausting psychological weight of biological hunger and reward signals. Your brain is constantly monitoring your energy, asking not just do I need calories, but how rewarding would it be to eat that specific food? For so many people, this noise is a constant, deafening background hum. When semaglutide reaches the brain, it actually alters these exact pathways. The biological intensity of those hunger and reward signals is massively reduced. The food noise finally quiets down. And for a lot of people, this is an incredibly emotional and liberating point. It proves their past struggles weren't a moral feeling or some lack of willpower. They were fighting a very powerful biological environment that the medication has now fundamentally changed, making daily food choices feel far less like a constant battle. Section 5. The systemic aftermath. Changing your biology is powerful, but what is the broader physical reality here? The crucial point is this. While the drug effectively changes your hunger signals, your body still absolutely needs nutrients. When you lose weight, it is not 100% fact. Without adequate protein intake and resistance training, you risk losing vital muscle mass. And muscle is essential for metabolism and physical function. The medication reduces your appetite so well that just eating enough protein can become really difficult, creating this wild paradox where you might lose the protective lean mass your body needs. It's a brilliant aid, but it's definitely not a replacement for proper nutrition. And that brings us to the inevitable question. Since this is an active biological intervention mimicking a hormone, what is the reality when that weekly intervention is suddenly removed? What happens if you stop taking it? The reality is, the underlying biology remains. The medication does not permanently rewire your DNA. If you stop taking it, the artificial GLP-1 fades, and your body's previous hunger signals, that rapid gastric emptying speed, and your old energy balance can just return right back. Think of it exactly like wearing prescription glasses. If the glasses help you see perfectly, taking them off doesn't mean the glasses failed. It just means the underlying visual problem is still there. For many, obesity is a chronic biological condition that requires long-term management. We now know that behind a single injection is this massive, intricate chain reaction spanning the pancreas, the stomach, and the brain. It is so much more than just eating less. Ultimately, understanding how these core concepts function leaves us with this vital, truly provocative question to consider. As we use these powerful tools to alter our biology, how do we make absolutely sure that when someone loses weight, they aren't just becoming lighter on a scale, but are actually becoming functionally, sustainably healthier? Think about that for a bit. Thank you so much for joining me on this explainer, and keep asking the big questions.